square, it is there. Please look at me, do not use pen, tell me the answer. 88 is nearer to 100. 88 minus 12. 88 minus 12 is 76. 88 plus 12 is 100. 12 square is 144. So which is 7744. 7744. Suppose 9991 whole square, it is there. It is nothing but 10 power 4. So 9991 minus 9 into 9991 plus 9 square. Plus 9 square. I hope the idea it is clear. Everybody, I hope the idea it is clear. If the numbers are nearer to the power of 10, if the numbers are nearer to the power of 10, then probably a square minus b square is the best logic. If to find out the tens place nature, a plus b whole square is the best logic. I hope the idea it is clear. Now see here. Now let us discuss some very, very important concepts. Write down concept number. Concept. Square of a number. Concept. Square of a number. Square of a number ending with 5. Square of a number ending with 5. Very, very interesting logic, sir. In the afternoon class, I am going to discuss a lot of models present on these concept. Squares of a numbers ending with 5. This will tremendously be helpful to find out the last two digits of a number ending with 5. Square of a numbers ending with 5. Square of a numbers ending with 5. Listen carefully, sir. There are three important types. One by one we will discuss. Type 1. Suppose if it is 15 into 15. 15 into 15 is 225. 15 into 15 it is 225. 25 into 25. 25 into 25 it is 625. 25 into 25 it is 625. 15 into 25. 15 into 25 it is 375. 15 into 25 it is 375. Why I took these three examples? It will help us to draw a very, very important conclusion. 15s are 225. 25s are 625. 15 into 25 it is 375. Now listen carefully to this conclusion. One is an odd number ending with 5. Again, one is an odd number ending with 5. Odd 5 into odd 5. What are the last two digits? Last two digits are 25. Odd 5 into odd 5. Last two digits are 25. 2 is an even number. Ending with 5 into even number ending with 5. Last two digits are 25. 1 is an odd number. 2 is an even number ending with 5. What are the last two digits? Last two digits are 75. Very, very important key point. When you multiply any two odd numbers ending with 5, any two odd numbers ending with 5, last two digits will be 25. Any two even numbers ending with 5, last two digits will be 25. Odd 5 into even 5, last two digits will be 75. Very, very important concept. Odd 5 into odd 5 it is 25. Even 5 into even 5 it is 25. Odd 5 into even 5, last two digits it is nothing but 75. I hope this concept is crystal clear to you. When you multiply any two odd numbers ending with 5, last two digits is 25. Any two even numbers ending with 5, last two digits is 25, else it is 75. This is the concept. Now let us do examples. Once we do examples, then the idea will be very, very clear to you. Very, very clear to you. Each and every concept, I will do as many examples as possible. Find the last two digits for. Find the last two digits for. Find the last two digits for. Now see the first example. 1235 into 3595 into 4365 into 4365. Three numbers product is given. We have to find the last two digits of that number. Last two digits. If the number is ending with 5, what we have to do? We have to just check the tens place nature. 123. 123, it is an odd number. Odd 5. 359, it is an odd number, odd 5. 436, it is an even number, ending with 5. Odd 5 into odd 5. What are the last two digits? 25. So it is 25 into even 5. 2 is an even number. So even 5 into even 5. Even 5 into even 5. What are the last two digits? 25. When two odd numbers are ending with 5 are multiplied, or any two even numbers ending with 5 are multiplied, last two digits will be 25. If the tens place has got the same parity, if one is odd, another is odd. If one is even, another is even. Last two digits will be 25, else it is nothing but 75. Odd into odd, ending with 5, 25. Even into even, ending with 5, 25. Odd into even, ending with 5. Last two digits is 75. First example clear? Do not check the entire number. Just check the tens place. It is an odd number ending with 5, odd number ending with 5, even number ending with 5. Odd 5 into odd 5, 25 into even 5. Even 5 into even 5. Last two digits it is 25. Last two digits it is 25. I hope the idea it is clear. Second question. One more question. 35795 into 4315 into 2335 into 5495 into 5495. We require the last two digits of a number. We require the last two digits of a number. We require the last two digits of a number. 3579, only tens place. It is odd. It is odd. It is odd. It is odd. Odd in odd 5 into odd 5, 25. Odd 5 into odd 5, 25. 25 into 25. Answer is nothing but 25. Answer is nothing but 25. Third question. Third question. 1245 power 48. 1245 power 48. Last two digits. 1245 power 48, last two digits. One is a traditional method, another is looking the problem with a different dimension. 1245 power 48, which is nothing but 1245 into 1245 and so on up to 48 times. 48 times. 1245 power 48 is 1245 multiplied 48 times. Multiplied 48 times. This is an even number. This is an even number. Even. Ending with 5. Answer is nothing but 25. Answer is nothing but 25. I hope the idea it is clear. Method 2. Method 2. Just by looking at a question, you can say the answer. 1245. 1245. Power 48, which is nothing but, if you see this question, if you see, one minute, sir. If you see this question, 48, it is an even number. 48, it is an even number. Are you all with me? If the power is an even number, if the power of any natural number, if the power of any natural number, it is an even number. If the power is an even number, then the number is a perfect square. Already we discussed, any perfect square ending with 5, tens place has to be 2. Any perfect square ending with 5, tens place has to be 2. Tens place has to be 2. I hope it is clear. Dheeraj, 55 will not come. From where 55 will come? Why? Because in any perfect square ending with 5, tens place is 2. Why it is 2? We already discussed. Why it is 2? We already discussed. Fourth question. Fourth question. See here. 7895. 7895. Power 160. Fifth question. 5315 power 87. 5315 power 87. Two more questions. 7895 power 160 Power is an even number. If the power is an even number, then the number is a perfect square. Last two digits will be 25. If the power is an odd number, you can write it as 5315 power 86 into 5315. This is 25. Tens place 1 is an odd number. 25 into odd 5. Even 5 into odd 5. What are the last two digits? 75. What are the last two digits? 75. I hope right from the starting basics onwards to an advanced level, I hope these problems are clear. Second problem, third problem, fourth problem, fifth problem. What if the power is an even number we discussed? What if the power is an odd number? Suppose if the question is 345 power 167, which is nothing but 345 power 166 into 345. These 24, 34 is an even number. Even 5 into even 5. Last two digits is nothing but 25. Everybody kindly reply it in the live chat if this concept is clear to you. I want only two types of comments in my enrolled batch. One is, if it is clear, you will say clear. If you got a doubt, you will mention the doubt. That's all. There will be, unless and until it is required, kindly do not write anything other than these doubts. Everybody, it is clear, right? Whatever the way I am saying, just learn it in the same way. Right after this class, watch the class again. Saturday and Sunday, you will listen to live classes, and weekdays, initially you will spend just 2 to 3 hours. Just 2 to 3 hours in revisiting it. Abhi, for you, question is 5315 power 87. 5315 power 86 into 5315. If the power is an even number, then the last two digits is 25. 531, it is odd 5. 25 into odd 5. What will be the last two digits? Even 5 into odd 5. Last two digits is nothing but 75. Last two digits is nothing but 75. Idea, it is clear, everybody? Now let us get into the next concept. Next concept. What is that we discussed? First concept. Concept 1. Two more concepts I'll explain in this slide. Concept 1. Even 5 into even 5. Even 5 into even 5. Last two digits is 25. Even 5 into even 5. Last two digits it is 25. Odd 5 into odd 5. Last two digits it is 25. Odd 5 into odd 5. Last two digits it is 25. Odd 5 into even 5. Odd 5 into even 5. Last two digits it is 75. This is the concept which we discussed. This is the concept which we discussed. Now see here. Concept 1. Concept 2. Now see here. Concept 2. Suppose A5 into B5. A5 into B5. We just discussed the last two digits of a number, but how to determine the entire number? Last two digits will be 25 when A and B both are odd. If A and B both are odd, last two digits will be 25. If A and B both are even, last two digits will be 25. If one is odd, one is even, last two digits will be 75. A is even, B is odd. Or A is odd, B is even, last two digits will be 75. Last two digits will be 75. So the number before is given by the logic A into B plus A plus B by 2. A into B plus A plus B by 2. This is nothing but, whenever you get any decimals, please ignore the decimals. I will also tell a proof. Suppose you got 3.1. Just ignore everything after dot. Write down 3. 3.1, it is 3. Even 3.9, it is also nothing but 3. It is also nothing but 3. A5 into B5. In the previous concept 1, we just discussed the last two digits of a number. Now we will discuss the entire number. Entire number. A into B plus A plus B by 2. Last two digits will be 25 or 75. This is nothing but in a mathematical language, greatest integer function. In simple non-mathematical language, ignore the decimals. Ignore the decimals. 3.1 is remove everything after dot. Remove everything after dot. Remove everything after dot. Proof. How you got this concept? A is nothing but it is there in the tens place. So this can be written as 10a plus 5. B is there in the tens place, which is nothing but 10b plus 5. 10b plus 5. 10a into 10b, which is 100ab, plus 50a, plus 50b, plus 25, plus 25. Can I say a into b plus a plus b by 2? Slash 25. I told you, if slash is kept before units place, tens place, hundreds place. If slash is kept before hundreds place, the value is nothing but into 100. I hope you are all there with me. So these is nothing but a into b into 100, 100ab. A plus b by 2 into 100, 50 into a plus b plus 25. I just a and b, if one is odd, another is even, carry will happen. I hope the proof is also clear to you. Simple way of doing this proof. A5 into B5. If A and B both are even, last two digits is 25. If A and B both are odd, last two digits is 25. If one is even, one is odd, last two digits is 75. If one is even, one is odd, the carry will come. Then one is even, one is odd, the carry will come, then it will result in 75. I hope the idea it is clear. If you take A value 2, B value 3, you will understand why 75 came into picture. Concept 1, only last two digits we did it. In concept 2, entire number before 25 or 75 we have done it. Before 25 or 75 we have done it. Now with every concept we have to do examples. Example. First one, 65 into 85. 65 into 85. A5 into B5. A and B both are even. Last two digits is 25. 6 8s are 48. 8 plus 6, 14. 14 by 2, 7. So answer is 5525. Answer is 5525. Suppose if it is 35 into 75. 35 into 75. Odd 5 into odd 5. 25. 7 3s are 21. 10 by 2 it is 5. Answer is 2625. Answer is 2625. If it is 25 into 95. These even, these odd. 75. 2 9s are 18. 2 plus 9 is 11. 11 by 2, 5.5. Ignore decimal. Answer is 5. Ignore decimal. Answer is 2375. Answer is 2375. Concept number 2. How to find out the entire number if they are multiplied and the numbers are ending with 5. What if the numbers are not ending with 5? That also we will discuss in the due course of time in multiplication. I hope the concept it is clear. A into B plus A plus B by 2. A plus B by 2, it is in bracket. That bracket is called as greatest integer function, which means in a simple language, ignore the decimal. 3.1 it is 3. 3.9 also it is 3. Sir, can I use this logic for a 3-digit number? Definitely yes. 105 into 125. A is 10 and B is 12. A is 10 and B is 12. So these 25. 10 12s are 120. 10 plus 12 is 22 by 2, which is nothing but 11. So answer for this question is 13125. Answer for this question is 13125. Everybody, after the concept is over, you know what to do. You will either ask me a doubt or you will say if it is perfectly clear to you. Is it perfectly clear to you? Even 5 into even 5, 25. Odd 5 into odd 5, 25. Odd 5 into even 5, last two digits is 75. Crystal clear, concept by concept, problem by problem. Notes also will be uploaded in the notes section. You can watch the class. You don't need to waste the time in writing the notes again. I have prepared a well-defined structure for you. Just to follow the structure. Everybody kindly reply. Any doubts, kindly reply. Anybody got any doubts? Everybody, it is clear? Shall I get into the next concept? Kindly make a habit of replying in the comment section in case if it is clear to you. Is this clear? Avika says, explain the 3-digit concept. Avika, for you, 105 into 125. A is 10, Avika. B is 12. So, A into B. 10 into 12, it is 120. 10 plus 12 is 22. 22 by 2 is 11. 120 plus 11 is 13125. 13125. 13125. Only 2 things should be there in the comment. I am little particular with respect to the professionalism even in the comment platform. Any doubts? Avika, I hope it is clear. Saurabh is telling, Saurabh Kushwaha. I think you are saying your name to everybody. Please tell me whether this concept is clear with no doubts. Shall I get into the next concept? So, concept 1 over concept 2. Concept 1 and concept 2. Now see here. Concept 1 and concept 2. Now concept 3. Now concept 3. Then we will solve the problem. Concept 3. Concept 3 is derived from concept 2. Concept 3 is derived from concept 2. What is concept 2? A5 into B5. A5 into B5. Answer is nothing but A into B plus A plus B by 2. A plus B by 2. Ending with either 25 or 75. Here we have to ignore the decimals. 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 Concept 3. What will happen if A is equivalent to B? Let me understand what will happen. A is equivalent to B. If A is equivalent to B, A5 into A5. If A is even, it will become even 5 into even 5, 25. If A is odd, odd 5 into odd 5, again 25. 75 case will not arise. 25. A into B. A into A, B. A square. A plus B by 2. A plus A, 2A by 2, it is A. So it is nothing but A into A plus 1 ending with 25. A into A plus 1 ending with 25. I hope the concept is clear. What is the concept? What if A is equivalent to B? A5 into A5. A square plus A into A plus 1 ending with 25. A into A plus 1 ending with 25. I hope the idea it is clear. That is the reason in Vedic Maths 1 is added because of this reason. This is a generic approach. Condensed approach is what if A is equivalent to B? A5 into A5. So examples we will solve. One is 65 into 65. A and B both are same. So it is 25, add 1. 7 6 are 42. 7 6 are 42. Why we are adding 1? Because it is A into A plus 1. A into A plus 1. 45 into 45. 45 into 45. Again it is 25. A into A plus 1. A into A plus 1. So answer is 2025. Answer is 2025. I hope this proof is clear to you. Why plus 1 came into picture? Why plus 1 came into picture? Why? Because when A is equivalent to B, A into B, A square plus 2A by 2. A into A plus 1 ending with 25. So this is nothing but A into A plus 1. This is nothing but 6 into 6 plus 1. If anybody asks a proof, why that plus 1 came into picture, you can actually discuss concept number 1, then concept number 2, then concept number 3, then concept number 3. I hope the idea is crystal clear to you. 2 examples. Sir, can I do it for a 3-digit number? 125 into 125. A5 into A5, both are even. Last two digits is 25. A into A plus 1. 12 13s are 156. 12 13s are 156. So you can do it for a 3-digit number, 4-digit number, and so on. D is for a 3-digit number. D is for a 3-digit number. I hope the idea it is clear. A into A plus 1 ending with 25. A into A plus 85 square is 85 into 85. A5 into A5. 5 5s are 25. A into A plus 1. 70 to 25. Now one interesting derivative. Now see this 10th question. Very, very important question, sir. Very important question. Let us do a comparison. Let us do a comparison of two multiplications. 45 into 45. 45 into 45. 83 into 87. 83 into 87. What are the two comparisons that you can make? Now see here. These are the units places. What is 5 plus 5? 10. What is 3 plus 7? 10. That means units place sum is 10. Sir, can it be 10? It can also be 10 square. It can also be 10 cube. It can also be anything of the form 10 power k. Anything of the form 10 power k. You can also use this logic in 396 into 304. 396 into 304. You can also use this logic in 4992 into 4008. 4008. So what we'll do is, for this it could be unit digit. For could be 96 plus 400, 992 plus 8000. So what we'll do is, we will generalize it. For a 2-digit number, it will be units place. Except the leftmost place. Except the leftmost place. Except the leftmost place. Remaining digits sum. That will help you to understand for a 3-digit number, for a 4-digit number, and a 5-digit number. For a 2-digit number, 5 plus 5, it is 10. It is unit digit. For a bigger numbers, it could be except leftmost place, remaining digits sum is 10, 100. 5 5s are 25. Add 1. 5 4s are 20. Here also 7 3s are 21. 5 into 5 is 25. 3 7s are 21. Add 1. 9 8s are 72. 9 8s are 72. Same logic. The logic whatever we discussed holds good under two conditions. Holds good under two conditions. Leftmost place should be same. Leftmost place should be same. And remaining digits, sum should be, sum should be 10 power k. Remaining digits, sum should be 10 power k. Sum should be 10 power k. Leftmost digit it is 4. Leftmost digit it is 8. Remaining digits 5 plus 5 it is 10. 3 plus 7 it is 10. 396 into 304. 96 plus 4 is 100. 96 4s are 384. How many digits are there? 1, 2, 3, 4. 4 digits. 384 is a 3-digit. Add a 0. Add 1. 4 3s are 12. 4 3s are 12. Answer is 120384. 4992 into 1008. 992 plus 8, which is 1000. Sum should be either 10 or 10 square or 10 cube and so on. 992 into 8. 2 8s are 16. 73. 72 plus 7, 79. 1, 2, 3, 4, 5, 6. 6 digits. I got 4 digits. Add 2 zeros. Then add 1. 5 4s are 20. Answer is 2000 7936. 2000 7936. Nitendra, good question you have asked. I hope I clarified your question by taking 396 into 304. Suppose if the question is 49 into 41. 49 into 41. Step number 1. What is 9 plus 1? 9 plus 1, it is 10. 9 ones are 9. Innate 2 digits, it is 0, 9. Innate 2 digits, it is 0, 9. Add 1. 5 fours are 20. See how many digits are there. Answer after product should take the number of digits which are there in this circle. 3 and 7, 2 digits. 21, it is a 2 digit. 9604, 4 digits are there. 96 fours are 384. I got a 3 digits. So answer is 120384. 992 into 8, 7936. 1 2 3 4 5 6. 6 digit आना है, 4 digit आ गया. So दो digit आगे लगाओ. So 5 fours are 20. I hope the answer it is clear. I hope the idea it is clear. So 83 into 87. Answer is 7221. Very, very important concept. How the derivative of concept number 3 is used? If the leftmost digit is the same. If the leftmost digit is same and the sum of the remaining digits. If the leftmost digit is same and the sum of the remaining digits. If it is 10 power k, then if it is 10 power k. Sir, what if it is not 10 power k? Suppose if it is, let me take an example. Suppose if it is 72 into 77. Can I use this logic? No. Both the conditions should be true. 7 is same. What is 2 plus 7? It is not 10 power k. This concept cannot be applied here. 52 into 58. 52 into 58. Leftmost digit is same. 2 plus 8 is also same. Let me take 68. Sum of the remaining digits is 10. But leftmost digit it is not same. This concept is used only if satisfies two conditions. What are the two conditions? Leftmost digit should be same and condition. Both the conditions should be true. Leftmost digit should be same and sum of the remaining digits is 10 power k. Leftmost digit should be same and sum of the remaining digit should be 10 power k. I hope the idea it is clear. Kindly reply it in the live chat. Concept after the concept is over. Instead of me asking you every time, kindly acknowledge it. If it is clear, you got a doubt, welcome to ask a doubt. Not a single doubt will go unanswered in my live classes. Everybody kindly reply. Next one, next concept. Now see here. Now you can solve all these questions orally. 96 into 94. 6 plus 4, 10. 6 fours are 24. 10 nines are 90. 10 nines are 90. 298 into 202. 298 into 202. Leftmost digit it is same. 98 plus 2, 100. 98 twos are 196. 4 digits, add a 0. 3 twos are 6. 3 twos are 6. This already we did it right now. 3996 into 3004. 996 fours are 3984. 1, 2, 3, 4, 5, 6. 2 digits. Add 1. 4 threes are 12. 4 threes are 12. Answer for this question is 1200 3984. Concept is clear. Again I am repeating where the concept is used, where the leftmost digit is same. When the leftmost digit is same and the sum of the remaining digits and the sum of the remaining digits, if it is 10 power k, if it is 10 power k, this concept can be used. This concept can be used. Conditions applied. These two conditions should be to be satisfied or applied. Conditions should be satisfied. Both the conditions should be true. First condition is leftmost digit should be same. Second condition is sum of remaining digits is 10 power k. Sum of remaining digits is 10 power k. Now, already we discussed all these concepts. What is that concept that we discussed? Odd 5 into odd 5. Odd 5 into odd 5. 25, even 5 into even 5, even 5 into even 5, 25, odd 5 into even 5, 70. Odd 5 into even 5, 75. Solve it very, very fast. These four already we discussed. Power 22. If the power is an even number, last two digits it is 25. If the power is an odd number, 1, 2, 3, 5. Power 12 into 1, 2, 3, 5. Power 12 it is 25 into 1, 2, 3, 5. 2 is an even number. 1, 2, 3 it is an odd number. Even 5 into odd 5. Last two digits will be 75. Last two digits will be 75. Power is an even number. Last two digits it is 25. This is an odd number. This is an even number. Odd into even it is 75. This is an odd number. This is an odd number. Odd into odd which is 25. 7 is an odd number. 2 is an even number. Odd 5 into even 5. Last two digits it is nothing but 75. Last two digits, what is the concept that we discussed? Square of a numbers ending with 5. What are the three important learnings? Even 5 into even 5, 25. Odd 5 into odd 5, 25. Even 5 into odd 5, 75. Point number 1. Point number 2. A5 into B5 is A into B plus A plus B by 2. Last two digits is either 25 or 75. Second concept. Third concept. What if A is equivalent to B? Fourth concept, which is a derivative out of concept. If the leftmost digit is same and the sum of the remaining digits is 10 power k, you can apply that concept. I hope these are all clear to you. Another beautiful cat level question. Cat level question. As I told you, from basics to advanced level we will discuss. Question is, find the last two digits in the decimal representation of 1 by 2 power 902. 1 by 2 power 902. I want the last two digits. When you write the number in decimal, when you write the number in decimals, you want the last two digits. Now see here. 1 by 2 power 902. Very, very easy question. Examples will say, see, and then we will understand. 1 by 2 is nothing but 0.5. 1 by 2 square, it is nothing but 1 by 4, which is 0.25. 1 by 2 cube, 1 by 8, it is 0.125. 125 is nothing but the last two digits of 5 power 3. These is nothing but last two digits of 5 square. These is nothing but the last two digits of 5 power 1. Very, very important concept. Last two digits for 1 by 2 power n. 1 by 2 power n. In decimal representation, it is nothing but last two digits for 5 power n. Last two digits for 1 by 2 power n in decimal representation is nothing but the last two digits for 5 power n. 5 power n. So instead of giving an easy question, he just twisted the question. So the last two digits is equivalent to 5 power 902. 902 is an even number and the number is a perfect square. Answer is nothing but 25. Answer is nothing but 25. 5 power any natural number. 5 power any natural number greater than or equivalent to 2. 5 power any natural number greater than or equivalent to 2. Last two digits will be 25. Last two digits will be 25. 5 cube is 125. 5 power 4 is 625. 5 power 5, it is 3125. I hope the idea it is clear. Just by looking at the question, you might think that this question is a tough question, but actually it's a very easy question. Last two digits for 1 by 2 power n. Last two digits for 1 by 2 power n. In decimal representation, it is nothing but last two digits for 1 by 5 power n. 1 by 2 is 0.5. Last two digits is nothing but 0.5, which is 5 power 1. 1 by 2 square is 0.25, which is nothing but 5 square, which is nothing but 5 square. I hope the idea it is clear. Everybody, let me know whether this cat question logic it is clear to you. Is these idea techniques? Generic techniques. One by one we will discuss. What we did till now, we did the square of a number using a plus b whole square logic, a square minus b square logic, and some beautiful concepts related to the square of a number ending with 5 concepts. Generic techniques. Now see here. Key point 1. Key point 1. Total 3 key points I will explain. 11 square is 121. 11 square is 121. Suppose I want 101 square. 101 square. 101 between two ones. Between two digits I kept as 0. Am I right? Between two digits keep as 0. Between two digits keep as 0. 10201. Suppose if it is 1001 square, between two ones I kept two zeros. Between two ones I kept two zeros. 100 2001. 2001. Suppose if it is 1001 square, answer is nothing but between two digits keep 3 zeros. Very, very interesting generic technique. What do you mean by generic technique? Techniques used for a particular pattern based numbers. 11 square is 121. 101 square, 101. Between two ones there is a 0. Between two ones means between two digits there is a 0. Between two digits keep a 0. Between 1 and 2 I kept a 0. Between 2 and 1 I kept a 0. Between two digits there are two zeros. Between two digits there are two zeros. So between two digits keep two zeros and two zeros. Two zeros and two zeros. I hope the idea it is clear. 1000 2001. Key point 2. Key point 2. Key point 2. Suppose 11 square is 121. 11 square is 121. 11 square is 121. I need to solve triple 1 square. I need to solve triple 1 square. 11 contains two ones. Write down till 2 and come back to 1. Triple 1. How many ones are there? 3 ones are there. Write down till 3 and come back to 1. Write down till 3 and come back to 1. Suppose if 4 ones are there, what will be the answer? 1, 2, 3, 4, 3, 2, 1. 1, 2, 3, 4, 3, 2, 1. If 3 ones are there, answer will be 1, 2, 3, 2, 1. If 4 ones are there, answer will be 1, 2, 3, 4, 3, 2, 1. If 5 ones are there, if 5 ones are there, answer will be 1, 2, 3, 4, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 4, 3, 2, 1. I hope the idea it is clear. So generic techniques for the numbers which has got ones. 11 square is 121. 101 square which is 10201. 10201. 11 square 121. 3 ones are there. So 1, 2, 3, 2, 1. Go up to 3 and come back to 1. Go up to 3 and come back to 1. Go up to 3 and come back to 1. I hope the idea it is clear. 4 ones, 4 ones are there. Just 1 minute, sir. 4 ones are there. Answer is 1, 2, 3, 4, 3, 2, 1. 5 ones are there. 1, 2, 3, 4, 5, 4, 3, 2, 1. 1, 2, 3, 4, 5, 4, 3, 2, 1. Now, concept, generic techniques. Generic technique. The last concept, then we will answer all these questions. Generic techniques. Squares of the numbers. Squares of the numbers containing. Squares of the numbers containing. Squares of the numbers containing. Squares of the numbers containing only threes, only threes, only six, only threes, only six, and only nines. Square of the numbers containing only 3, only 6, and only 9. Only 3s, only 6, and only 9. Another important concept related to generic technique. There is a pattern that comes in these three numbers. Let us see the pattern. Square of the numbers containing 3 square, it is 9. In a 2-digit format, it is 09. 6 square, it is 36, 2-digit format. 9 square, it is 81. 9 square, it is 81. Before 3, I am adding another 3. 33 square. One more 3 I am adding. So, before 9, add a digit. Before 0, add a digit. Before 3, I am adding 2 3s. Before 9, add 2 digits. Here also add 2 digits. 4 3s square, 0 9. Before 9, I am adding 3 digits. Here also add 3 digits. What is the digit that we need to add before 9? It is 1 less than 9. 1 less than 9 is 8. 1 more than 0 is 1. 3 square is 0 9. 33 square. Before 3, one more 3 is added. So before 9, add a digit. Before 0, add a digit. Some specific patterns. 1 less than 9 is 8. 1 more than 0 is 1. So 1 less than 9, 8, 2 3s are added. 1 more than 0, it is 1. Before 3, 3 3s are added. 111 0, 888 9. 111 0, 888 9. Again I am explaining. These logic holds good for all the numbers for only 3, only 6 and only 9. Only 3, only 6 and only 9. 3 square is 0 9. Before 3, another 3 is added. So before 9, one more digit. Before 0, one more digit. These 1 less than 9, these 1 more than 0. 1 less than 9, 1 more than 0. 1 less than 9, 1 more than 0. How many 3s are added before 3? That many 8s will come, that many 1s will come. That many 8s will come and that many 1s will come. 66 square. 66 square. Before 6, I am adding one more 6. So before 6, one digit will come. Before 3, one digit will come. These 1 less than 6, these 1 more than 3. 1 less than 6, 1 more than 3. 666 square. Before 6, 2 6 are added. So 1 less than 6 and 1 more than 3. 1 more than 3. I hope you understood the idea. Suppose if it is 4 6 whole square, what will be the answer? 36. 1 less than 6 and it is 1 more than 3. And it is 1 more than 3. Very interesting logic on how to find the squares of a number containing only 3, only 6, only 9. 99 square. Before 9, 1 more 9 is added. 1 less than 1, 1 more than 8. 999 square. 1 less than 0 and 1 more than 8. I hope you are understanding. These 1 less than the unit digit. These 1 more than the given number. 1 less than the given unit digit. 1 less than 1 is 0. 1 more than 8 is 9. Suppose 49 square. It is 999 0001. 999 0001. I hope these three generic techniques are extremely clear to you. Only 3s, only 6 and only 9s. Now 6 square, it is 36. How many 6 are added? 4 6 are added. So 4 5s will come here. 4 4s will come here. 4 4s will come here. I hope the idea it is clear. 9 square is 81. 9 square is 81. How many 9s are added? 5 9s are added. So 5 zeros will come here. 1 less than 1. 1 more than 8 is 5 9s will come. Answer is 5 9s followed by 8 followed by 5 zeros ending with 1. Very interesting generic techniques of how to find the squares of a number for 1s, for 3, for 6 and for 9. Only 3s. 3 square 0 9. 33. One more 3 is added. 1 less than 9, 1 more than 0. 2 3s are added. 1 less than 9, 8 2 times. 3 3s are added. 3 8. Only 3, 6 and 9. These are the squares of the numbers containing only 3s, only 6 and only 9s. Only 3, only 6 and only 9s. Now see here. This question, 111 square. What will be the answer? 1 2 3 2 1. Answer will be 1 2 3 2 1. These nothing but 3 square is 0 9. 1 less than 9 and 1 more than 0. 1 less than 9 and 1 more than 0. Idea clear? So 111 whole square is 1 2 3 2 1 and 4 3's whole square is 1 1 0 8 8 9. 1 1